Alright, so our goal today is to use relationships of sides, angles, diagonals, and transversals of parallelograms. So what we're going to be doing is finding different properties of parallelograms, meaning if it applies to a parallelogram, it also applies to everything that falls underneath a parallelogram, like a rhombus or a rectangle or a square. Okay, so though we're learning these specifically about parallelograms, they don't only apply to parallelograms because parallelograms are broken down into other types of shapes as well. Okay, but they're all types of parallelograms, which is why it applies to them. A parallelogram, so just from the previous definition that we've talked about, is just a quadrilateral with two pairs of parallel sides. So we can draw what that looks like. This. We know that these sides are parallel and these sides are parallel, and that's what makes a parallelogram. What's that? We have two new words, or vocab terms. Consecutive angles and opposite angles. Consecutive angles are angles that share a side. Okay, these are going to be ones that are right next to each other. So if I draw this parallelogram again, and I label 1, 2, 3, and 4, angles 1 and angle 2 are consecutive angles because they're next to each other. They share a side. Okay. What would be another example of consecutive angles in that figure? 2 and 3 would be consecutive angles. What else? 3 and 4 would be consecutive angles. What else? 1 and 4. Very good. So opposite angles are angles that are then across from each other. So let me draw this parallelogram in again. And the example here would be angle 2 and angle 4 are opposite angles. They're across from each other. What would be another example of opposite angles in that diagram? 1 and 3. Very good. So the ones that are across from each other, 2 and 4, or 1 and 3. Now those are terms that we're going to need to know for these theorems that we're going to learn. The first theorem says that opposite sides of parallelograms are congruent. So that's one of the properties. If you have a parallelogram, so here, if we have a parallelogram, then I know that this side is going to be congruent to that side, and this side will be congruent to that side. They'll have the same length. Now the next one that talks about consecutive angles is actually going to be review. If I cover up this part of this diagram, I have two parallel lines and a transversal. Do we remember what we call angles 1 and 2? Same side interior angles. Very good. So these are consecutive angles. So we look at angles that are right next to each other. These are considered same side interior angles. Even if I look at these two, 2 and 3, these are still the same side of the transversal interior to the parallel line, so they're same side interior angles. So consecutive angles in a parallelogram are always going to be same side interior angles. So what does that mean? What was the property? If we have parallel lines, then same side interior angles are, do we remember? Remember, they were either supplementary or congruent. These ones were the supplementary ones. Because corresponding, so if I put a 1 up here, 1 matches 1. They're in the same location. So 2 is a linear pair to 1, just like it has to be a linear pair to that one. Okay, so it's, or technically not a linear pair, but supplementary. Okay, so consecutive angles in a parallelogram must be supplementary because that's what we know about same-side interior angles. So that part is actually review. It's just using previous knowledge, even though it applies to these parallelograms. The next theorem says that opposite angles of a parallelogram are congruent. So that means if we have this parallelogram, then we can label A has to be congruent to C. Okay, because opposite angles are congruent. I know that those two angles have to be the same. And if you look, they kind of appear to be the same if you have a parallelogram that appears to be a parallelogram. Okay, those are both the obtuse angles. These are both the acute angles. So D and B then have to also be the same. So then we have an example here of how we can use these properties. If we know one angle in a parallelogram, we can actually find all 4 angles, or find the other 3. If I know that A is 120, what else do I know? C is 120 also. How can I use that to help me find D and B? Oh, you're going about it the hard way. So you could use the idea that all 4 have to add the 360, subtract the 2 that you have, and then take what's left and divide by 2. You could do that, but that's kind of extra work. Go ahead. Yes, you can use consecutive angles. If this is 120, what does this one have to be? 60, because they have to be supplementary. They have to add to 180. So here this one's going to be 60, and once you have that one, then you know its opposite angle must also be 60 degrees. Yes, both of those will work, and it doesn't matter because we know all those properties, so either way would work. You could use the idea that the whole, the sum of all 4 has to be 360, or you can use these new rules that we just learned. Let's flip it over. And we have a couple examples here. It says to use algebra and find the missing sides and angles of these parallelograms. So, looking at these 2 angles that we have labeled here, what do you know about those 2 angles? They have to be congruent because they're opposites. So if angles are congruent, that means their measures must be equal. That means we're going to set them equal to each other. I know that 6y plus 4 has to equal 3y plus 37. I'm just going to use algebra skills in order to solve for y. What am I going to do first? Subtract the 3y on both sides. Then what? Subtract 4 on both sides. Three y equals 33. Then what? Y has to be 11. If I plug this back in up here, I can find the measure of angle D, which I need. So plugging it back in, 6 times 11, which is 66, plus the 4, we're going to get 70 degrees for angle D. What should I get for angle B? 70. So that's what I'm looking for. I have to plug it in to verify, but hopefully I get 70. 33 and 37 make 70. So angle B is also 70 degrees. That should say the measure of angle D and measure of angle B are both going to be 70 degrees. So far, so good? All right, I also have some sides marked in this diagram. What do I know about side AB and side DC that are marked? They have to be equal to each other because opposite sides of a parallelogram are congruent. So again, I'm also going to take the 3x minus 15, set that equal to the 2x plus 3. I work at solving that. What do I do first? Subtract the 2x on both sides. I'm going to get x minus 15 equals 3. Add 15 to both sides. X is 18. Okay, well now I'm going to have to plug that in. What's 2 times 18? Plus 3. 36 plus 36 plus 3 is 39 for DC. I'm hoping that AB is the same because they're supposed to be. 3 times 18 minus 15. What do we get there? 39. So we're good there. We get 39. Were the two sides supposed to be the same? Are they supposed to be both 39? Yeah, I marked them equal to each other because I know that they were congruent. Okay. On this one, what do I know about the two angles that are marked? They have to add to 180. So when we do this one, we're going to set it up. We're going to have to add them to equal 180. So we're going to take the two angles. They have to be 5x plus 10 plus 2x minus 5. They have to add to 180 when I do this setup. Okay, I'm not setting them always equal to each other. I have to say, based on where the angles are marked, what do I know about them? Are they equal, or do they add to 180? And that's how you have to do your setup. All right, combine like terms. We have 7x plus 5 equals 180. Subtract 5 on both sides. Divide by 7 on both sides. And we get that x is 25. Plug it in. 2 times 25 is 50. 50 minus 5 is 45 degrees there. 5 times 25 plus 10 is 135. But wait a minute. Weren't those supposed to be the same? No, they're supplementary. Are 135 degrees and 45 degrees, are those two angles supplementary? Do those two angles add up to 180? Well, let's double check. Yes, they do. That's what was supposed to happen. I want to verify that the rule that I said actually happens. So I know that the measure of angle A is 135 degrees. That was a overkill on my degree symbol. And then for the measure of angle D, it's 45 degrees. What do I know about these two sides that are labeled? What do I know about the sides opposite from each other? They're congruent, so I know that this side and that side are equal, or congruent, so I'm going to set the 2y minus 10 equal to the 3y minus 25. Subtract 2y on both sides. Add 25 to both sides. Y is going to be 15. Plug it in. 2 times 15 is 30. 30 minus 10 is 20 for BC. And AD is 3 times 15, which is 45. 45 minus 25 is also 20. Were those two supposed to both be 20? Yeah, they're supposed to be the same. Okay. All right. The last theorem that we're going to learn about parallelograms is that the diagonals of parallelograms bisect each other. What does it mean to bisect? Cut in half. So if I take a straight edge and I draw in the diagonals that connect the opposite angles. I'm going to do that for both shapes here. So if I can see that this is a parallelogram and I can look and see that there's diagonals drawn in, I know that this diagonal is being cut in half by this diagonal and vice versa. Okay? That means this diagonal right here is being cut in half. This is a midpoint of it. I also know that this diagonal is being cut in half. Okay, so that center point is also a midpoint of that diagonal. So you can mark those labels on there and show what parts are actually congruent there. Now, the diagonals are not the same length, because if you think about this, you can squish C and A together and D and B get further apart. So they're not going to be the same length, the diagonals there. This diagonal is actually going to be longer than this diagonal, which you can kind of visually see that. Can you kind of see that? So that's why I can't mark them all congruent, but I can say that these ones are cut in half and this diagonal is cut in half. That's why you have to use different marks, though. Okay. So that means that if we were to use algebra and have labels on these, I could mark this equal to that, or this equal to that, solve and use algebra and find the lengths of the diagonals if that was necessary. The last theorem just states that if you have parallel lines and you know that they're spaced evenly apart, they're always spaced evenly apart on any transversal. So what it says is if you have this diagram here, you also know that these would be marked congruent because they're still spaced evenly apart. If I draw in another transversal.
Good morning, teachers. Pardon the interruption. Please send down all students, last name B, grades 11 and 12. Thank you.
If I drew in another transversal, I also know that those are evenly spaced apart still. Does that kind of make sense? If I know they're evenly spaced apart here, they're still evenly spaced because those lines are parallel. Okay? That's the end of those notes. If we take a look at that assignment, 1 through 6, make sure you show me some work, like even if you're typing it into your calculator, write out what you typed in. Okay, that's showing your work to find X for those. 7 through 11, you'll have some algebra skills to practice. It also says to find the value of the missing variable and the length of all the angles or all the sides. So plug it back in and make sure you label your sides or your angles there. That continues on from 12 to 13. 14, 15, and 16, we did not do an example like this in our notes, but if you mark your diagonals as being bisected like we did in the notes, so remember this would be a midpoint, right? And this would be a midpoint of this one. You should then be able to say, okay, I know then that these two are congruent, set them equal just like we did with the angles and the sides. 17 through 26, all you're going to do here is you can see that they're all parallel lines, okay? And it says in the figure the horizontal lines are parallel and PQ. So PQ is here, is equal to QR, which is equal to RS. So they're evenly spaced over here. That means on any transversal, they're evenly spaced. Okay, so that's using that idea. So you guys have the rest of the time to work.